Hey there, welcome to another video of math problem solving. This is Bharat Divyang from Zugzwang Academy, and today's problem is one of very elegant problem that I've seen. So let's define what elegance in problem setting is. So oftentimes you, the problem solver, do not look at the world from the problem setter's perspective. But if you're a problem setter, you don't want to set a problem that's so hard that 50% of your, target audience, your students, don't even answer it. That's not the point. What you want is that 100% of your audience understands it, 90% of them know how to solve it, and still only half of them get it right because of blind spots involved, because they don't observe the details, they don't observe the nuances. And this is one such problem. Okay, so let's get started. And I'll stop you exactly at the place where I'd say, okay, this is where the mistake could possibly come. So you have two integers that are inserted into five numbers that's already there. So let's write down the five numbers. So let's change this. The five numbers are 3, 3, 8, 11, and 28. Okay, so now you need to insert two numbers, A and B, such that you want to double the range. Okay, so what is the range currently for this? So let's write down the range of the current one is 28 minus 3, which is 25. Okay, the mode of the current set of 5. Mode is the number that's repeated often, which is 3 and 3. And the median, which is the central number, which is in this case 8. And you want to change this to a different range, but the same mode and the same median. So the mode and median are still 3. Sorry, the mode is still 3, the median is still 8, but the range needs to double. It needs to become 50. Okay, this is what you want to do. Now, what is the maximum possible sum of the two additional numbers? Okay, now let's look at this. If I have 8 as my median of 5 numbers, and 8 still needs to be the median of 7 numbers, then you know for sure that A needs to come to the left and B needs to come to the right. Okay, so this is what you would want to do. So let's assume that A is less than B. Now, if this is the case, then B obviously is going to be larger than 28, because if it's less than 28, then you won't be able to find a range that's about 50. And also, you want to find out the maximum value of A plus B, not the minimum value of A plus B. For example, you could probably keep B to be less than 28. So let's say B is 27, in which case A has to go negative, right? And the moment A is negative, A plus B is going to have a much smaller value. So that's the reason you would want to still work in the positive integer territory. So now, if you still want it to be here, you know that A has to be to the left and B has to be to the right. And most likely you would say, okay, the smallest number I have here is 3. So I can probably fit in 3 here. And B can be 53. Right? Fair enough. So A is 3 and B is 53. Together, I would have 56. Now, this is what, half the students would probably arrive at. But that's not the correct answer. I want you to pause the video here and think about what the correct answer is going to be. Is it possible to find something which is even larger than 56? Okay, welcome back. And the answer to the question I just posed, is it possible to find a number, the sum of A plus B, to be larger than 56? And the answer is yes. So the way you do it, you still keep 3 to be the smallest number that's there, which means B is still 53. That's the only way you will get the range to be 50. But A can be any number that's less than 8. Because it can't be 8. The moment you make it 8, you would end up making 8 also as a possible mode. And in fact, when you have two different modes, sometimes you find the average of it. Whereas here, you want it to be less than 8, but it could be greater than 3. So it could totally be 7. So if the 5 numbers could essentially be 3, 3, 7, 8, 28, 53. Giving you the same median of 8, giving you the same mode of 3, and giving you a range that is between 3 and 53, which is 50, which is double the original. And the blind spot that a majority of students are going to have is the fact that oftentimes when you think B is greater than 28, you think A is less than 3 for the maximum possible range, and therefore you end up saying A could be 3 because that way the mode is still 3. So there are three threes and it totally works, and somewhere the brain just justifies the entire approach and says it's totally fine. Except there's a fine blind spot that many people will miss. So the answer is not 56, the answer is actually 60. And that's what makes this problem a very elegant problem. Now, if you like this, please do like and share this video and subscribe to the channel, and I'll see you in the next video. Thank you so much.